Hi, I'm Dr. J, and this is a video about making scatterplots using the ggplot2 package within the R statistical software. This video is meant for those who are brand new to using R, frankly, and in particular to using ggplot2 to construct graphics. So if you've never seen it before, this is definitely the video for you. If you have seen it before, maybe there's still something that you can gather out of what I'm going to talk about today. All right, so the first thing is we need to make sure that we have the ggplot2 package installed. And actually for one other piece, I'm going to also be using the dplyr package. Both of these exist within the tidyverse, and so my recommendation is just to go ahead and install the tidyverse if you haven't done that already. Here's the command install the packages tidyverse. I should mention that down below in the description there's a link to this script, so you don't have to just watch the video and pause it and try to type it out, but in fact you can just run the commands as I am running them. Okay, so you should install the tidyverse package, and then we need to load it up in this R session, and that's what this library tidyverse command does. So I'm just going to hit command enter, and that's going to load up the tidyverse, including the two packages we actually need, ggplot2, which you see right here, and dplyr, which you see right here. Okay, now for the purpose of this video, I'm going to use a data set that's built into R, so nobody has to go searching for the data set. It's just going to be right there when you install R. The data set is called ToothGrowth. The data set, you can see down here, has three variables, len, sup, and dose. Not the most informative variable names ever, but we can take a look at the help file. And here's the help file down below. And this tells us that this is an experiment done on guinea pigs to understand how vitamin C affects tooth growth. And if we look down a little bit farther, we can see that there are three doses at these levels, 0.5, 1, and 2. And that corresponds to the dose variable. And we have two different delivery methods, which is abbreviated here as sup. Right, so here's the supplement type. And this VC and OJ, so OJ stands for orange juice, and VC stands for vitamin C. Maybe we wanted to use ascorbic acid instead, just to distinguish it from the vitamin C that's in orange juice. Nonetheless, this is the data set we're going to be taking a look at, and it's, it's simple enough that for an introductory video it makes sense, but complicated enough that there's a bit going on in this data set. So in particular, we're interested in understanding how the supplement delivery method and the dose affect the length of these odontoblasts, basically these teeth in these guinea pigs. Okay, and we can see straight away that we have orange juice is the delivery method for 30 of the pigs. For the other 30, it is this vitamin C or ascorbic acid. And we can see, not entirely clearly right now, but the minimum dose is 0.5, maximum is 2, and it turns out that we have only 3 doses, 0.5, 1, and 2, just like the help menu tells us. Okay, so let's just get into taking a look at the data. And so one of the first things you might want to do is construct a scatter plot, maybe of looking at dose by length. Okay, so that's the goal for the first part of what we're doing here. Now, when we are using ggplot, the main starting command is function is the ggplot2 function. Okay. Right after that command, what we want to tell ggplot is where the data are located. That is, what data set are the data located in. So this is a feature of constructing graphics using ggplot2, that all the data are going to be contained within a data frame. So the data frame we have here is called ToothGrowth. So that's the first argument to this ggplot function. And then the second argument is going to be an AES. AES stands for aesthetics. And the aesthetics are basically telling ggplot what you want your graphic sort of to look like in terms of what's on the x-axis, what's on the y-axis. In a moment, you'll see different colors or different shapes. Okay, so right here what we're saying is that on the x-axis, we want dose. On the y-axis, we want the length of those teeth. Okay, now at this point, you haven't told ggplot what kind of graphic to construct. Right, you haven't told it physically what it should look like, you've just told it what variables are on the x and y axis. And so to construct a scatter plot, we are going to use the geom_point function. And you can see what we do here is we have ggplot, we tell it the data frame, we tell it what's on the x and the y axis, then we have a plus at the end of that line. And this will be common when we're adding components into this ggplot graphic. So what we're going to add then is geom_point to construct our scatter plot. So if you go ahead and run those lines, Right, now down below here, right, you can see the graphic. The graphic has dose on the x-axis, length on the y-axis, and now it's abundantly clear that we only have 3 doses, 0.5, 1, and 2. And we have these circles that represent the each individual guinea pig and how much their length was for the given dose that they had. Now right away, we're kind of missing a variable, right? There's this variable of the type of supplement, that is the delivery method that was given to the guinea pigs, and so it would be good to represent that on this plot somehow. And so there's a couple ways we can do that. The first way is that we can say, look, color the points by that supplement type. So this seems like a pretty good way to go. So there it is. So now we can see with this sort of reddish color is the orange juice, and the bluish color is this vitamin C or ascorbic acid. And one of the great things I think about ggplot2 graphics are the legend gets constructed automatically, right? So we didn't have to do anything separate to get this legend over here, right? We have this, oh, I can't really highlight it apparently, right? Where we have on the right side, it says sup, and then it says OJ and VC, right? That just was automatically generated. Now we have another option. Instead of using the color, we could use the shape. And so all I've done here is change the code from color to shape, right? And if we do that, right, now we have circles representing OJ and triangles representing this vitamin C or ascorbic acid. Now, when I only have one other variable that I want to represent on the plot, I will often use both the color and the shape to represent that object. And that's pretty easy. If you did have more variables, you might want one variable to represent the color and a different variable to represent the shape. But here, since I only have that one extra variable, I'm going to go ahead and color by the supplement type and make the shape the supplement type. So I'm going to do both at once. Right, and there we go. And you'll notice again that the legend is just automatically updated. Right, so now we have reddish circles are orange juice and bluish triangles are vitamin C or ascorbic acid. So let's talk about that legend for a second. When you're constructing graphics, you might want a little more control about where that legend is, or maybe you don't want it at all. Okay, and so we're going to go through the process of moving that legend around a bit. But before we do that, I just want to point out this new way that I'm writing the code. So what I'm doing now is I'm actually going to assign the graphic that we've constructed so far into an R object that I'm going to call G for our graphic. Right, so our graphic here is just getting saved, and when you run this code, it's not obvious. Can I like clear all plots? Okay, that's at least a different plot. When I run this command here, nothing actually happens, right? But if I were to then just look at G, which is now this saved graphics object, it would now update the plot to the plot that we've actually constructed. Okay, so if you save the ggplot2 graphic into an R object, it doesn't automatically get shown to you. You have to then print out the object. Now, the reason I want to do it this way is because now I can sort of focus you on the different code that we're using to get the different legend positions. Okay, so this G right here is just the object that we've created so far, which by default puts the legend on the right-hand side. If we wanted to remove the legend, we can say legend.position equals none. So there we go, legend is gone. You know, that's not a common situation for me. Usually I want a legend there and I want the default one. I might change the colors a bit. That's, but some points you might want to not have the legend there. If you wanted the legend on the bottom, which I think looks pretty good for this particular graphic, you can just say legend.position is bottom, and now you see the legend is underneath dose there on that x-axis, right? And you'll see also that by default it's now horizontal rather than vertical. And this can often be useful to sort of save space or have less white space in our graphic, right? When we had our original graphic, we have a lot of this white space above and below that legend, right? And by putting the legend on the bottom, right, we have less white space. I guess there's still white space there to the right and to the left of that legend. Sometimes you might want to put the legend actually within the graphic in order to save even more space. And so here we're going to do that by legend.position and sending it a vector that basically tells it where on the x-axis to be and where on the y-axis to be as a percent, or actually as a proportion of the total range of the x and y-axis. So this says put it 75% of the way right on the x-axis and 25% of the way on the y-axis. If we run that code, it looks like this, right? So now we have the legend right inside the graphic For this particular graphic, I'm not sure I like that too much, but this is all sort of personal preference about what works for you and how much space you really need to save. Okay, so let's go back to our original graphic with the legend on the right-hand side. One thing that's not ideal about this graphic is that all the points are lined up vertically above the dosage levels that we had in our experiment. And so in particular, it's hard to tell how many observations are there. For example, if we look at dose being 2 and the lowest value here there, this is a single triangle, at least it looks like a single triangle, but if there happened to be another observation exactly at that value of length, right, then we might have multiple triangles that are overlapping and we wouldn't be able to tell, right? And in fact, there could be 100 triangles there. Well, there can't, because we know that there was only 30 in the whole experiment and probably 10 of those were in dose 2. But, right, there could be multiple observations sitting under that single triangle. And so a common thing to do in Scatterplot is something called jitter. So jitter just adds a little variability to the point so that if there are overlapping points, they get separated and we can see both of them. And so I'm going to do the same thing I did before. I'm going to save the graphic that we have so far, which at this point is really just telling ggplot that we want this on the x and y and this color and this shape, but it says nothing about what kind of plot to construct. And so now we're going to focus our attention on what we can do with this geom_point function. Now in particular, there's going to be an argument called position, and here we're going to set the position to be a dodge, and we're going to tell it the width. Okay, so here we go. This is now, this is actually, I was focusing on jittering and then I did dodging first in the code, but I hope it's pretty clear what happened here, right? What happened here is that above each of the levels of dose, right, all of the OJs got shifted a little bit to the left, and all the VCs got shifted a little bit to the right. Okay, and now the nice thing is that you can separate and see clearly the group of points that are associated with OJ and the group of points that are associated with VC. We haven't solved the other problem that I mentioned. That is, what if the points are overlapping? That could still be a problem. And so now we're going to change our code. Rather than position dodge, we're going to have position jitter. Okay, and so now we're adding a little jittering instead of doing the dodging. And now we can see the points, right, that might have overlapped before are now separated a bit. Okay. Now, typically in my code, I don't necessarily write the position jitter and use geom_point, but I actually use this other geom jitter, right? It does exactly, okay, should I say that? I think it does exactly the same thing as the previous line. And so that's, what the graphic would look like if you use that geom jitter instead. But now, if we want to use dodge, there's no equivalent geom dodge, right? I'm not sure why that's the case. If anybody knows, go ahead and let me know. All right, now you can also do both of those two together. So here we have position jitter dodge, okay? And now we have to specify the width for the jittering and the width for the dodging. And again, these values you really just want to sort of play around with to get a feel for what you think looks good, right? What doesn't distort the data too much, but still makes it clear to a viewer what the heck is happening. Okay. All right, so that's a really useful technique when constructing scatter plots that have vertically or, for that matter, horizontally aligned points, just to make sure that you can see all the individual points and also to make sure that you can compare different groups. Okay, so let's take that graphic and now we're going to do some other things to it. Okay, one thing is that we might want to add some lines here that try to give a viewer a visual representation of what's happening with length as you change dose, right? And so the simplest thing you can do is add to the previous plot a smoothing line, okay? And so by default, if you just use this geom_smooth, we have those lines right here. And you can see a couple of things. One is that the lines are color-coded just like our data are. The legend is updated to use those lines in addition to the points. We also have these sort of bands around the points. That gives you some quantification of uncertainty in that line. These particular lines by default, R tells you, uses the method called LOS. For those who are just getting into R and things, don't worry about it, right? Just think about it as a way to sort of smooth out the points. Okay. Now, what if we want to get rid of these bands that show you the uncertainty? We can do that by doing SE equals false. This SE stands for standard error, so we're removing that uncertainty quantification. there's a lot of warning messages there. I didn't remember that that was the case. But here we go, right? So now we've just removed those uncertainty measurements and we just have the lines, in case that's helpful. Now for some of you, you might be familiar with regression. And with regression, we might be interested in constructing the straight line rather than these smoothing lines that can be all flexible, right? And so we can construct that by changing the method here to LM rather than the default method. And now we get our straight lines. If we want to remove the uncertainty, we can do that as well. Okay, so I don't think this is a great model for these data, but we're going to see an improved model in a second that still uses regression. But if you wanted to put regression lines on there, you can. Okay, so now the next thing I want to do is I want to talk about these labels, right? These labels are actually pretty terrible for anybody to understand what's going on. So we have LEN, DOSE, SBUPP, right? If we hadn't read the help file, we wouldn't really know what these variables are, and so we'd like to make the graphic more clear. Similarly, the levels of SUP, OJ, and VC, it's not quite clear what those are. And so we're going to construct better labeling in our entire graphic. In order to do it for the labels of SUP, we actually have to change the values in the data set, okay? So here's where we use the dplyr package both for the mutate function and this recode function. And we basically tell R that what we want is, instead of OJ, we want orange juice. Let's just spell it out. Instead of VC, we want ascorbic acid, okay? And so this line just constructs a new data frame called D, where it has, instead of OJ and VC, it has orange juice and ascorbic acid. All right. So that's good because that will change the legend. Okay. Now, if we also want to change the labels on the plot, we can do that typically within the ggplot2 code to construct the graphic. So up here is everything we've done before, right? That hasn't actually changed. We're still using this jittering and dodging. But now we're going to add labels. We're going to add a title. We're going to add a better x-axis label, a better y-axis label, and a better label for the legend. And there's multiple ways you can do this. I'm going to do it right here using this labs command and changing both the color and shape to have the same label. If they had different labels, then you actually end up with two legends, right? One for the color and one for the shape, which we don't really want here in this example. But in your future work, that might be exactly what you want because the color and the shape are representing different variables. Okay, so let's put that all together. Right? And now we can see, look, this plot looks much better. I haven't zoomed the plot yet here, right? So now we can see this plot, right? It has a title up at the top. The x-axis label is sort of very clear. The y-axis label, right, should have a unit there, but I could not find the units in the help file, nor in the original paper. I'm assuming maybe it's millimeters. Yeah, that could be 2 inches, 2 centimeters. Yeah, so it's probably millimeters, but I didn't want to take that guess. But anyway, this is already getting to look like a pretty nice graphic, I think. But now let's add a few bits more to this. So here, one thing is, if you look at the plot, you can see that the levels of dose are multiples of 2. So you go from 0.5 to 1 to 2. And when you have data that are constructed that way, you might be thinking that actually the phenomenon occurs on a logarithmic scale, right? And so we can easily construct this graphic on a logarithmic scale here just by adding to our original graphic that we have this scale x log 10. That's for the x-axis. If we wanted the y-axis, we would do scale y log 10. So here we go, and now we can see that 0.5, 1, and 2 are equally spaced, which is what happens when you have the same multiple between them on a logarithmic axis. We can add the regression lines back into this plot, which now that we're on a logarithmic scale actually makes a lot more sense. Like this looks like a pretty reasonable model for these data. We can change the theme. So I'm not a huge fan of this sort of gray background with white grid line. I prefer the theme BW, so we can change the theme here. Got to print it out. So now we have a white background with gray lines, and we have this nice dark border around the entire plot. Personally, I like that. So this is just some of the things that you can do pretty much with any ggplot2 graphic to make it all look better. You can also put this all together in a single line of code. So here it is, right? And then we get the same plot. Well, this video still took me 20 minutes, even though I tried to cut out all the other plot types that I had previously. But I hope it was useful to you. I think you can really do amazing things with ggplot2. I think scatterplots are amazingly, I guess, useful in a number of different situations. So if you appreciate this video, I'd appreciate a like. If you think these videos will be helpful to you in the future, go ahead and hit that subscribe button, get notifications turned on. I have one last thing to talk about. So I should have said that before so you didn't run away, but whatever. And that is the idea of faceting. So faceting is a way to make many small plots very quickly. With this example, we're not going to have too many small plots, but I want to get you the idea. So we're going to start with our same graphic that we had before, but now we're going to use a couple of different facet functions. So the first one is facet wrap, and we're going to wrap by the supplement type. And so what you can see that happens is now each supplement type is in its own window, right? And for these data, you might actually want them in the same window, but now if you had other things to facet by, you could get the quantities you wanted to compare close to each other. Now, what if you wanted these not side by side, but one on top of each other? Well, you can change the number of columns to 1. That's one way of doing it. Now you can see the labels are above each of these plots. Another function you can use a facet grid, which I typically use if I want to facet by 2 different variables. So you'll put one on the left of this tilde and one on the right. Since we only have one variable here, we just put a dot as a filler for saying there's nothing on this other side. Okay, but that gives you a graphic that puts them side by side again. If you want them on top of each other, you can do this. And now the labels you see are on the right-hand side, right? The orange juice and ascorbic acid labels. Anyway, so I think this faceting technique is really helpful, all right, in combination with coloring and shapes and X and Y and so forth. Anyway, I hope you liked this video. Until next time, have a great one.